This is a little gyro project using a MPU6050, but only using one axis, and like a basic helicopter tail gyro. So we've got Arduino Nano, we've got a receiver, underneath here is the MPU6050, and we've got a servo and a battery. So if I plug the battery in, so you see the light flashing on the Arduino. That's doing a calibration. It looks for 5 seconds of stability. And now, if I move the stick on the transmitter, we can see what would be the tail rotor servo moving. And I've got it set so that when I push the stick to the left, it makes the servo rotate to the left. So that's the sense. Now if I rotate it to the left, you can see the servo fighting the direction of travel. So that's basic settings out the box, and you can set directions and gains and things by editing the sketch. Now at the moment this wire here isn't connected, but if I plug that in as well, that's the auxiliary channel, and it lets me set the gain of the gyro from the transmitter. I've actually got it on a dial at the moment, but you'd normally have 2 or 3 position switch. So I've set it on quite a low gain now, and you can see when I move the when I rotate it, you know, the servo is still working servo is still working from the transmitter, but it's not correcting very much there on movement because we're on a low gain. If I turn the gain up, now a small rotation will give a big correct. I mean, that would make a helicopter oscillate, but you can tune it to what you think is appropriate. Now all that's one side of 0 on this pot. If I go the other side of 0, then we're in heading hold mode. So that's heading hold mode with a lowish gain. If I move the stick now, you see the servo moves round to try and get to the new heading, and then when the heli actually rotates, you see that typical sort of heading hold servo action. Now I'm not touching the stick, and it's trying to get us to about there, isn't it, at the moment. If I give it a stick full of input, now I've let go of the stick, but the helicopter still wants to rotate until it gets to there. I've set the what should we call it, the maximum error between where it currently is and where it's trying to get to 60 degrees, which I think is perhaps reasonable. So if you're doing pirouettes and you let go of the stick, even if the helicopter hasn't been able to keep up with the demand, it's still going to stop within 60 degrees of rotation, and you could edit that in the sketch if you wanted to. So that's about it. The Arduino Nano, of course, is a bit bulky. Could use a Pro Mini instead, but the intention is to migrate the sketch across now over to a AT Tiny, so that it'll all fit in a smaller case. Okay, thank you for watching.